Assalamu alaikum wa rahmatullahi wa barakatuh. Students, today we are going to start exercise 11.2 of surface of class 10th, surface areas and volumes. Surface areas and volumes. Let's have question number 1. It says a solid is in the shape of a cone standing on a hemisphere. A solid is in the shape of a cone standing on a hemisphere. Let me try it. This is a solid which is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter. So radius is 1 centimeter and the height of the cone is equal to its radius. Height of the cone, that means from here to here, is equal to the radius. Radius is 1 centimeter. Because it says both the radii is 1 centimeter, so height of cone is 1 centimeter as well. Find the volume of the solid in terms of pi. What you need to do, you need to find the volume of this solid in terms of pi. In terms of pi means you need not to put the value of pi in. Now what I can do here, radius of base is equal to radius of cone is equal to radius of hemisphere is equal to height of cone. All of these are same and that is equal to 1 centimeter. Then, therefore, volume of solid. Volume of solid here is equal to, volume means the capacity. So volume of solid is equal to volume of cone plus volume of hemisphere. Volume of cone plus volume of hemisphere. Now volume of cone, you know by the formula table, volume of cone is equal to 1 by 3 pi r square h plus volume of hemisphere is 2 by 3 pi r cube. Now radius is same, so you can take pi, 1 by 3 also you can take out. You can take 1 by 3 out, then pi, then r square. So what is left here? H plus twice r. Got it? Then I can say this is 1 by 3 pi. Now r is 1, so it's 1 square times 1 plus 2 times 1. Then I can go, this is pi by 3 times 2 ones 2 plus 1 3. Now 3 gets cancelled, so you are left with pi. Now volume is in cubic units, so pi cubic centimeter. Pi cubic centimeter, and that's your answer. Make a note. Now let's have another question. Question number 2. Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at two ends by using a thin aluminum sheet. Rachel was an engineering student who was asked to make a model, and model is in the shape of a cylinder with two cones attached to it. Let me draw it. Model was something like this, just like that, in the shape of a cylinder, just like this, with two cones attached to it, like that. This is a cylindrical portion, then it's like this, and this, and like this, and this. So this is a cylindrical shape. Two cones are attached to this cylinder. Yes. Then it says the diameter of the model is 3 centimeter. Now the diameter of model is 3 centimeter. We know this must be the diameter because the diameter of the circular part of the cylinder is the diameter of the model. So it's 3 centimeter. And its length is 12 centimeter. The total length of the model is 12 centimeter, like this. If each cone has a height of 2 centimeter, each cone has a height of 2 centimeter. So this is 2 centimeter and this is 2 centimeter. Because this is the height of cone. So find the volume of air contained in the model that Rachel made. You need to find the volume of this model. Now volume of air contained in the model. Now the volume of air contained in the model will be equal to the capacity of the model, which can what the air it can hold. That means, in other words, in simpler words, we need to find the volume of this very model. And so you go like this here. Here, diameter of cylinder. You can write diameter of model first. Diameter of model is equal to diameter of cylinder is equal to diameter of cone is equal to 3 centimeter, which implies that radius of model is equal to radius of cylinder is equal to radius of cone is equal to 3 divided by 2, and that's equal to 1.5 centimeter. Total height of model. Total height of, or you can say total length of model. Total length of model is equal to 12 centimeter, which implies that, now if I need to find height of, first you can write this, first write down the height of cone. Now height of cone is 2 centimeter. Then total height, total length of model. Total length of model is 12 centimeter. This is the total length of model. It's 12 centimeter, which implies that now the total length of the model is 12 centimeter. You can say h dash, height of cylinder. Height of cylinder will be equal to the total length minus this length of this cone and this length of this cone. That means, in other words, I can easily say 12 minus 2 plus 2. This is the length of cylinder now. Because the total length of the model is 12 centimeter. So 12 centimeter, if it's the total length, then I can subtract this length first and then I can subtract this length. So I'll get the length of the cylinder. So 12 minus this 2, then minus this 2. In other words, 12 minus whole 2 plus 2. That will give you 12 minus 4, and that's 8 centimeter. That's the height of the cylinder. Now if you observe carefully, height of the cylinder is different than the height of the cone. So I make this h as h dash. Now I differentiated the height of these cone and cylinder as h and h dash. Going further, therefore, volume, since volume of a model, I can get the volume of model by adding volume of cylinder plus twice volume of cone, because we have two cones available here. So volume of cylinder is nothing but pi r square h. This is the volume of cylinder, you know, by the formula table. Then twice volume of cone is 1 by 3 pi r square h. Now this h and h is different. Volume of height of cylinder, we represented this as h dash. So now pi r square radius is the same. Now I can take pi r square out. Now what is left? H dash plus 2 by 3 h. 2 by 3 h. Now I can put the values in pi as 22 by 7. Now 22 by 7, you will assume pi as 22 by 7, or you will take pi as 22 by 7 unless stated otherwise. Times, now r being 1.5, so 1.5 square times h dash is 8. Then plus 2 by 3 times, now what is this h? This is 2, then goes like this. Now I can use the calculator. First of all, you can solve this bracket. So 2 times 2 is 4, 4 by 3. Now 8 3 is 24, 8 3 is 24, 24 plus 4 is 28, 28 divided by 3. So it goes 28 times 1.5 times 1.5 times 22 divided by 7, 3 is 21. So it will give you 66. It will give you 66. Yes. So it gives you 66 square, sorry, cubic centimeter, because volume is in cubic centimeters. So 66 cubic centimeter is the volume of this model. Therefore, volume of air contained in the model is 66 cubic centimeter, and that's your answer. Make a note. Now, question number 3. A gulab jamun contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with 2 hemispherical ends. We have a gulab jamun in the shape of a cylinder. This is a gulab jamun. of a cylinder with two hemispherical ends. Just like this and like this. This is a gulab jamun. Now the dimensions. Each shaped like a cylinder with two hemispherical ends with length 5 centimeter. The total length is 5 centimeter. Total length of the jamun is 5 centimeter. Then, and diameter 2.8 centimeter. This is a diameter 2.8 centimeter. 2.8 centimeter is the diameter. Yes. Then it says how much sugar syrup, find approximately how much sugar syrup would be found in 45 such jamuns. Let us first find the volume of this one jamun. Here, what you are given is here diameter of jamun is the diameter of cylinder is the diameter of hemisphere, and that is how much? 2.8 centimeter, which implies that radius of jamun is equal to radius of cylinder is equal to radius of hemisphere is equal to 2.8 divided by 2, and that will give you 1.4 centimeter. That is the radius of jamun. Then you have the total length. Yes. Total length of jamun, that is how much? 5 centimeter. This is the total length, which implies that height of cylinder. Now you can easily find height of cylinder because you know radius of hemisphere is equal to, I told you yesterday, radius of hemisphere is equal to height of hemisphere. Remember this point again. Radius of hemisphere is equal to height of hemisphere. That means this height of hemisphere will be equal to its radius. That means this is 1.4. This is 1.4 as well. So the height of cylinder is equal to total length minus this minus this. So in other words, height of cylinder is 5 minus 1.4 plus 1.4, and that will give you 5 minus 2.8, and that will give you 2.3 centimeter. 2.2, sorry. 8, 19, yes, 2.2. So 5 minus 2.8, 2.2 centimeter is the height of cylinder. That's it. Therefore, volume of jamun. Now we can find volume of jamun. That is equal to volume of cylinder plus twice volume of hemisphere. Volume of cylinder, you know, pi r square h plus twice volume of hemisphere is 2 by 3 pi r cube. Now radius being the same, so you can take it out. So pi r square times h plus 2 2's 4 by 3 r. 4 by 3 r. Yes. Then you can put the values in. 22 by 7 times radius is how much? 1.4 squared. Now h is 2.2 plus 4 by 3 times radius is 1.4. Now let us solve this. First of all, I can solve 4 times 1.4 is 5.6. 5.6, then I go divided by 3, then plus 2.2, times 1.4 times 1.4 times 22 divided by 7. You get 25.05. 20 of the order is of the order 25.05. Of the order means it's approximately equal to 25.05, because you got the non-terminating non-recurring decimal expansion is no, it's the terminating decimal expansion. Recurring is non-terminating recurring decimal expansion, so it's 25.05066666. Then it goes again 5006666. So I wrote approximately 25.05 units cubic centimeter. This is what? This is volume of 1 jamun. Now it says, question says that 1 jamun contains sugar syrup up to 30% of its volume. Since sugar syrup contained in 1 gulab jamun is what? 30% of its volume. It is equal to 30% of its volume. It says sugar syrup contained in 1 gulab jamun is 30% of its volume. Now 30% of its volume means 30 by 100. Of means times of volume. Volume is 25.05. 25.05. Now let me solve this. 30 times 25.05 divided by 100, and that will give you 7.515. 7.515 cubic centimeter. Now after that, sugar syrup contained in 1 gulab jamun is 30% of its volume, that is 7.515 cubic centimeter. Now after that, therefore, sugar syrup contained in 45 such jamuns. I went out of the line. Therefore, sugar syrup contained in 45 such jamuns is equal to 45 times 7.515, and that will give you 338.175 cubic centimeter, and that is of the order 338 cubic centimeter. That means approximately we have 338 cubic centimeter of sugar syrup contained in 45 such gulab jamuns. Hence the required amount of syrup. Hence the required amount of syrup is 338 cubic centimeter, and that's your answer. So make a note. Let me refill the marker. Now the next question. A pen stand made of wood is in the shape of a cuboid. There happens to be a pen stand which is of the shape of a cuboid. So let me try it. This is a pen stand. In the shape of a cuboid. With 4 conical depressions to hold pens. We have 4 conical depressions to hold pens. So they are like this. One over here. One, two, 3 and 4. These are 4 conical depressions to hold pens. The dimensions of the cuboid are 15 by 10 by 3.5. 15 centimeter by 10 centimeter by 3.5 centimeter. That means length, breadth and height are 15, 10 and 3.5 respectively in centimeters. The radius of each of the depression is 0.5 centimeter. Now radius of this each depression is 0.5 centimeter. If I can zoom out this, it's like this. The radius here is 0.5 centimeter. Go like this. Then, and depth is 1.5 centimeter. 1.5 centimeter. This is the depth, 1.4 centimeter. 1.4 centimeter depth of the height of the cylinder. Find the volume of wood in the entire stand. Now you need to find the volume of wood because this whole box is made up of wood. Find the volume of the wood. So it goes like this. Here length of cuboid is equal to 15 centimeter. Breadth of cuboid is 10 centimeter. Height of cuboid is 3.5 centimeter. The radius of cone is 0.5 centimeter. Then height of, let us say h dash, because it's different from height of cuboid. So height of cone is equal to 1.4 centimeter. So these are our dimensions. Therefore, volume of stand is volume of cuboid minus 4 times volume of cone, because that capacity has been taken off from the stand. So volume of cuboid, you know, it's LBH. volume is, yes, LBH, minus 4 times volume of cone is 1 by 3 pi r square h. Now this is h dash. Then you go 15 times 10 times 3.5, then minus 4 by 3 times 22 by 7 times 0.5 square times h dash is 1.4. Now let us solve this. You'll get 4 times 22 times 0.5 times 0.5 times 1.4 divided by 21. Yes. So it gives you 523.53. 523.53 cubic centimeter. This is the volume of stand. Hence, now question says, what is the, find the volume of the wood in the entire stand. Hence, the required volume of wood is 523.53 cubic centimeter, and that's your answer. Volume of stand is equal to the volume of wood in the entire stand. That's equal to 523.53 cubic centimeter. Make a note. Now question number 5. A vessel is in the form of an inverted cone. Vessel is in the form of inverted cone. This is an inverted cone. Vessel is in the shape of an inverted cone. Its height is 8 centimeter. Height is 8 centimeter. And the radius of its top, which is open, is 5 centimeter. By the top it's open and radius here is 5 centimeter. It is filled with water up to the brim. Brim means full. Water is filled up to the brim. When lead shots, each of which is a sphere. Now lead shots, which is of the shape of a sphere. This is a lead shot. This is a lead shot. Lead shot of the shape of a sphere. Lead shot, each of which of the sphere of radius 0.5 centimeter. So radius here is 0.5 centimeter. This is the radius of the sphere. Drop it into the vessel, 1/4 of the water flows out. Now when these lead shots are dropped into the water, what will happen? But natural, the water will flow out because water is filled up to the brim, and you know when anything will be put inside the vessel, the water will flow out. Now it says when these lead shots are dropped into the vessel, water is 1/4 of the water is flow 1/4. Yes, it's 1/4. Yes, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. Now you need to find the number of lead shots which are being dropped in the vessel, by which 1/4 of the water is flowed out. Now you go like this here. Height here, radius of cone is the radius of vessel. Radius of cone is equal to 5 centimeter. Height of cone is 8 centimeter. A radius of sphere, let us distinguish it with dash. So r prime or r dash. Radius of sphere is 0.5 centimeter. This is the radius of sphere. Then we can say one thing first. Since volume of cone, now volume of cone is equal to volume of water. Volume of water inside. Now volume of cone is volume of water inside. Yes. Because it's filled up to the brim. So volume is equal. Which implies that volume of cone is equal to volume of water you can write volume of cone is equal to volume of water inside it. Volume of cone is equal to volume of water spilled out plus volume of water left. Is it right? Volume of cone is equal to volume of water inside it. No doubt about that, because you know it's filled up to the brim. Now after that, that means volume of water inside it is equal to volume of water spilled out plus volume of water left. Now whatever is spilled out and whatever is left, they will be equal because that's the water inside it. So I wrote volume of cone is equal to volume of water spilled out. Spilled out means what flows out, plus volume of water left. Which implies that now I can find volume of cone easily. We need to find the number of lead shots. Volume of water. Sorry, we need to find the number of lead shots. Don't work like this. Sorry. I thought we need to find the volume of water spilled out. We need to find the number of lead shots. Number of lead shots. I write like this: let n number of lead shots. PB is the symbol for lead, it's plumb bomb. Let n number of lead shots be dropped in the vessel. Let n number of lead shots be dropped in the vessel. Okay. Then I can go now we know one thing, n times volume of sphere, because lead shot is of the shape of a sphere, will be equal to 1/4 1/4, because the volume of this, by the Archimedes principle, the volume of lead shots, total number of lead shots, the whole volume of these lead shots will be equal to the water that flows out from this vessel. So 1/4 volume of water, 1/4 volume of water spilled out, like this, which implies that n times volume of sphere is equal to 1/4 volume of water, volume of water 1/4, what it says, 1/4 of water flows out, 1/4 of the water, 1/4 of the volume of water. Write down like this: volume n times volume of sphere is equal to volume of water spilled out. Volume of sphere, so whatever the number of lead shot is, the combined volume of these lead shots will be equal to the volume of water that flows out. That means I can write number of n times volume of sphere is equal to volume of water spilled out. Yes. Now how much water is spilled out? That is equal to 1/4 volume of water. Volume of water inside the vessel. Inside the vessel. And how much is that? Which implies that n times volume of sphere is equal to 1/4 volume of water inside the vessel will be equal to volume of cone. Now we are good. Yes, because it's filled up to the brim, which implies that n times volume of sphere, you can easily find 4/3 pi r dash cube, because radius is r dash for sphere, is equal to 1/4 times, now volume of cone is 1/3 pi r square h. Now this r is different. Now what I can do, I can cancel out pi and pi. I can cancel 3. Dividing pi throughout, pi gets cancelled. Multiplying 3 throughout, 3 gets cancelled. Anything else? Now you can substitute the values. N times 4 times r dash is 0.5, so it's 0.5 cube. Then I have 1/4 times r is 5 square times h is 8. It's like this. Now I can solve this. You have 5 times 0.5 times 0.5 times 4, it's 0.5. So n times 0.5 is equal to, now let me solve this, 25 times 8 times 4, it's 50. Which implies that, therefore n is equal to, then you go 50 divided by 0.5, that will give you 100. Now n is 100, hence the required number of lead shots, hence the required number of lead shots dropped are 100, and that's your answer. Kindly make a note. Now after that, we have the next question. Question number 6. It says a solid iron pole consists of a cylinder of height 220 cm and base diameter 24 cm, which is surmounted by another cylinder of height 60 cm and radius 8 cm. Find the mass of the pole given that 1 cubic centimeter of iron has approximately 8 gram mass. See, we have one cylinder surmounted by another cylinder. So it goes like this. We have one cylinder like this. Like this. We have one cylinder surmounted by another cylinder. It's like this. So it says of height 220 surmounted by another. So 220 centimeters is the height of this. Let us say this is cylinder 2. Name it cylinder 2. Name it cylinder 1. So 220 centimeter is the height of this cylinder. Base diameter 24 centimeter. Base diameter 24 centimeter, which is surmounted by another cylinder of height 60 centimeter. The height of this cylinder is 60 centimeter and radius 8 centimeter. Here radius is given 8 centimeter. Find the mass. Given that 1 cubic centimeter has approximately 8 gram mass. So we go like this. Here height of, here a radius of cylinder 1 is equal to 8 centimeter and height of cylinder 1 is equal to 60 centimeter. Diameter of cylinder 2 is 24 centimeter, which implies that radius of cylinder 2 is equal to 24 144 divided by 2, that is 12 centimeter. Got it? Then height of cylinder 2. Height of cylinder 2 is 220 centimeter. Got it? Then, therefore, volume of pole. This whole structure is pole. Volume of pole is nothing but volume of cylinder 1 plus volume of cylinder 2. Volume of cylinder 1, let me have this as R dash and H dash because this is different than that of the first. So volume of cylinder 1 is equal to pi R square H plus this is pi R dash square H dash. Now I can take pi common, so I'll get this and this. Pi, it says use 3.14. 3.14 times R is 8 square times H is 16 plus R dash is 12 square times H dash is 220. Now let me solve this. 144 times 220, 31682, 31684 times 60 plus 355 times 3.14. So I got 111,532.8. 111,532.8 cubic centimeter. Cubic centimeter. Now, this is a volume of pole. Now, question says that 1 cubic centimeter of iron has approximately 8 gram mass. Now, mass of pole per cubic centimeter. Mass of pole per cubic centimeter is equal to 8 gram. Is equal to 8 gram. Is it 8 gram? Yes. Which implies that mass of pole for 111,532.8 cubic centimeter is equal to 111,532.8 times 8, and that is equal to how much? 111,532.8 times 8 is 89226.24 grams. So this is the required mass of pole, or you can convert this to the kilograms, so you'll get it in kgs. You know, it's divided by 1. It's like this. Remember this conversion. 1 meter is equal to 100 centimeter. Now cubing both sides, what you'll get? 1 cubic meter. 1 cube is 1, meter cube is meter cube, then it's 1, 2, 3, 4, 5, 6. Sorry, I need to convert to kilograms. I need to convert gram to kg, so I just divide 1000, so normal thing. 89226.24 divided by 1000, so I get 89.22. 532.8 times 8. So it's 89226.2.4 grams. 89226.2 grams and divided by 1000. So I'll get 89226.2 divided by 1000. Now on divided 1000 I'm in kgs. So that means now this expression is kilogram. So that is equal to 892.26 kg. And that's your answer. Hence the required mass of the pole is 892.26 kg. And that's your answer. Please take a note. Now after that, question number 7. A solid consisting of right circular cone of height 120 cm and radius 60 cm standing on a hemisphere of radius 60 cm is placed upright in the right circular cylinder full of water. You have a cylinder like this. This is a cylinder. Now it consists of a this cylinder contains right circular cone standing on a hemisphere like this. just like this. Right circular cone of height 120 centimeters. So the cone has height 120 centimeters. This is the height of cone. And radius 60 centimeter. Radius is 60 centimeter. Standing on a hemisphere of radius 60 centimeters, so radius is same, is placed upright in the right circular cylinder full of water. So this cylinder is full of water. Now it is being placed in the cylinder such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeters. So cylinder has radius same and height 180 centimeters. The full height of the cylinder is 180 centimeter. So what natural? The full height of cylinder is equal to height of cone plus height of hemisphere, because you know radius of hemisphere is equal to height of hemisphere. That means height of hemisphere is 60 and height of cone is 120. 120 plus 60 is 180. That is the total height of the cylinder. So you go like this here. Radius of base is equal to radius of cylinder is equal to radius of cone is equal to radius of hemisphere, and that is equal to 60 centimeter. Got it? Then height of cylinder is 180 centimeter. Then h dash, height of cone, it's equal to 120 centimeter. These are the dimensions. Since we can see one thing, that volume of cylinder is equal to volume of water present in it. Is it right? Yes. Which implies that volume of cylinder is equal to, no, volume of water present in it is equal to volume of water spilled out. Volume of water spilled out plus volume of water left. Volume of water left. Now this is what we need to find, volume of water left. Volume of cylinder we can easily find, which implies that volume of cylinder is equal to, now volume of water spilled out will be equal to the solid, volume of solid. Again Archimedes principle, because initially there was only a cylinder full of water. Now when you put solid into the cylinder, then some water spilled out, and the amount of water spilled out will be equal to amount or volume of the water spilled out will be equal to the volume of solid, what was put inside it. And volume, so volume of water spilled out is equal to volume of solid plus volume of water left, which implies that volume of cylinder is equal to, but volume of solid is nothing but volume of cone plus volume of hemisphere, then volume of water left. Now you need to find this volume of water left. Therefore volume of water left will be equal to volume of cylinder, volume of cylinder, then subtract this, volume of, transpose this, so it gets subtracted, volume of cone, transpose this as well here, so minus volume of hemisphere. Now you can find these three and you will get the answer. Volume of cylinder, you know, it's pi r square h, minus volume of cone is 1 by 3 pi, r is same, pi r square, h is different, h dash, minus volume of hemisphere is 2 by 3 pi r cube, and r is same. Now what you can take common, pi r square you can take out, then h minus 1 by 3 pi r square is out, then h dash, then minus 2 by 3 r. Let's have this. Then you can put pi 22 by 7 times, radius is 60, then squared, h is 180, minus h dash is 120 by 3, minus 2 times r is 60 by 3. So it goes like this. Then you can solve this. So you'll get 3 ones, 3 fours, 20 minus 40 minus so you got 1, 1, 3, 1, 4, 2, 8.57. Units are centimeters, so it's cubic centimeter. That's your answer. You can convert this in cubic meters also. Now like this, 1 meter is equal to 100 centimeter. You know that 1 meter is equal to 100 centimeter. Now cubing both sides, what you'll get, 1 cubic meter is equal to 1 cubic centimeter. So 1 cubic meter is equal to 10 lakh. Yes, 10 lakh cubic centimeter. Now 1 cubic centimeter is equal to 1 by 10 lakh cubic meters. Or you can say 1 cubic meter is equal to 1 million cubic centimeters. That means 1 cubic centimeter is equal to 1 by 1 million cubic meters. So these much cubic centimeters I divided by 1 million. So I'll be in cubic meters divided by 1. So I'll get 1 point, I'll get which is of the order 1.131 cubic meters. Now I'm in cubic meters, hence the required volume of water left. Hence the required volume of water left is approximately 1.131 cubic meters, and that's your answer. Make a note. Now let's have the last question of this exercise, question number 8. A spherical glass vessel has a cylindrical neck. So we have a spherical glass vessel with a cylindrical neck. This is a spherical glass vessel with cylindrical neck. Like this, and it says cylindrical neck 8 cm long. So this is 8 cm, 2 cm in diameter. This is 2 cm. The diameter of the spherical part is 8.5 cm. This diameter is 8.5 cm. By measuring the amount of water it holds, a child finds its volume to be 345 cubic centimeter. A child found the volume of this thing is 345 cubic centimeters. Check whether she is correct, taking the above as the inside measurements, and pi is equal to 3.14. So these are our dimensions. Let us see whether she does right or wrong. So here diameter of sphere is equal to 8.5 centimeter, which implies that radius of sphere is equal to 8.5 divided by 2, that's 4.25 centimeter. You got it? Now, height of cylinder, or first write down radius of cylinder, diameter of cylinder is equal to 2 centimeter, which implies that radius of cylinder is equal to 2 by 2, that is 1 centimeter. And height of cylinder is 8 centimeter. Therefore, volume of vessel is volume of sphere plus volume of cylinder. Volume of sphere is 4 by 3 pi r cube plus volume of cylinder is pi r square h. Now what we can take out? You can take pi. The radius is different, so I'll write r dash for cylinder. So here you can write r dash square. So you can take only pi out. So pi out, then we have 4 by 3 r cube plus r dash square times h. Use pi 3.14 times 4 by 3 times r is 4.25. Then you have cube plus r dash is 1, then square, then times h is 8. Now solve this. You'll get 4 times 4.25 times 4.25 times 4.25 divided by 3. Got this plus 8. Got this times 3.14. You got 346 It's of the order 346.51. 346.51 cubic centimeter, which is not equal to 345 cubic centimeter. So child was incorrect, hence child was incorrect at her calculations. So that's it. Make a note. See you next time. May Allah subhanahu wa ta'ala bless you all. Assalamu alaikum wa rahmatullahi wa barakatuh.